Hello people, welcome back. And in today's session, we are going to learn about what is the difference between sample and population. So first, let's understand the need of the sample. Why sample? Because if you start analyzing the entire set of data, that will be too time consuming and it will be too expensive. So entire set of data, when I say, it's a population. So instead of doing that, we can pick up some sample out of the entire population and we will be analyzing that sample, and whatever the result of the sample will come, which is the part of population, and based on that, we will be estimating the population parameter. So sample is a part of the population, or sometimes we call as a subset of population, while the entire data is your 100% data, which is called as a population. Example, let's say there are many times some elections happen, and these are the news channel or the survey agency. They do their opinion poll. Do you really think that they will go and ask each and every voter and whom you have voted, and based on that they will give you that who is going to win? Obviously, answer is no. So they just speak to few part or some part of the population and whom they have voted. Based on that, they will estimate that who is going to win the election. So they are going to do the sample analysis, and based on the sample, they are going to see who is going to win as a whole. That's what the population. So important part here, because if you are doing the population analysis, then population always work at 100% of confidence level, because you are checking each and every sample, each and every observation in the population. That means 100% you are checking. It's like maths. When you say maths is always, if I say 10 plus 10, if I ask you, then you will say mathematically 10 plus 10 is equal to 20. But when it's come to the stats, because this is just working on the subset of population. So when it's come to the subset of the population, which means by default, statistics works at 95% of confidence level. So there is a 5% of chance, which means 100% minus confidence level. 5% is the chance of error because it's a sample. So statistically, whenever you say that I am picking up the sample, based on that you are estimating about the population, that mostly it works at 95% confidence level. Sometimes based on the criticality, we can change the confidence level as well. So chance of error will be 5%, which means if I ask you statistically what is 10 plus 10, so the answer of 10 plus 10 will not be 20. Yes, it can be 20, but it may range from suppose 18 to 22. So what is this plus or minus 2 you are taking here? This plus minus 2 is margin of error, or the chance of the error that you are making, which means you have a confidence you will be like 10 plus 10 is 20, but it may range because you are not checking the 100% of the population. So it may range as in plus or minus 2. Many a time, let's go back to the election example. So many time when the survey agency, they are declaring their opinion poll. Is it always 100% that the candidate will win? Answer is no. Sometime candidate will win as large as the 95%, but sometime maybe in one or two case candidate may not win, they will lose, and some other person will happen. Why? Because we are not checking the 100% data. We are just taking the voters sample of 95% confidence level, few of them, and that's how this comes to the margin of error. Take another example. Let's say you are going to buy okra, or let's say lady's finger, we call. from the market. These are the vegetable. So there is a bulk of the ladyfinger is in front of you. So do you really go and check the softness of each and every? Answer is no. We don't. But we will pick up maybe one or two. We'll try to press them and check the softness. And based on that, we will ask them, okay, give me the 1 kg. I will buy. So just buying maybe 15, 20, 30 gram of the sample you are checking, and based on that you are buying the 100,000 gram or 1000 gram, that means you are picking up the sample and estimating the population. Every time you have picked up the okra or the lady's finger from the market and you used to go and see at home, is this all the 100% whatever you bought are the soft enough as you have checked in the sample? Answer is no. So what will happen? Couple of them or few of them may not be as soft, maybe that is hard, and you will say, okay, we are not going to cook them. Why? Because the risk what 5% you have checking of not checking each and every sample, that is coming up here, and that's how your sample estimation is not equal to the population estimation. We always try that my sample estimation should be equal to the population estimation. For that, we pick up a specific sampling method, sampling strategy, and specific sample size, which you will be learning in the next sessions. I'll take another example for the sample and the difference. Let's say you are cooking rice. So rice you are cooking, suppose let's say 200 gram. Rice you are cooking, which means it has the multi-thousand of the grains. But when rice is cooked or not cooked, how you will decide? You will pick up maybe half a spoon of the rice, or let's say few grains of the rice from the bowl, and then you will pick up in a spoon and you will check the softness of that. And based on the half a spoon of the rice, you are deciding that your entire bowl of the rice is cooked or not cooked. That is means you are picking up the sample and estimating about the population that entire rice is cooked or not cooked. So many times we make some error, which is called as a sampling error. When will happen? When sample size is not selected correctly, or it's not the statistical sample size, or the sampling method which you have chosen is incorrect, right? So to avoid the sampling error, which means I want to gain a confidence that my sample should be representative about the population, whatever my sample is telling, so sample estimation should be equal to the population estimation. So for that, what we are supposed to do? We are supposed to select the right sample size with the right sampling methodology. And this sample estimation is equal to population estimation. This is what we want. But in case sample estimation is not equal to the population estimation, we wanted to avoid this sampling error. So that's what the sample means. Sample means it's a subset of the population, or the part of the population, which will represent your population. Population is your entire set of data. Sample always work at 95% confidence level. There is a 5% of chance of error that sample estimation may not be equal to the population estimation, and that's what the sampling error will come. And to avoid the sampling error, we should be taking the right sample size with the right sampling method. So this session, this much, and you will be learning more about the sampling and population in the upcoming session. Thank you so much, people. Have a good day.